Okay, hello. So we're getting closer to training, but in order to do that, we need a GPU. So there's two options you can take, or actually three. Let's say three. Like the first option is to get your own GPU. Then I am going to demonstrate that here in this video, at least installing it on Windows subsystem for Linux. Second option is to go somewhere like Lambda Labs and rent your own instance for GPU training. And I think there's a pricing right here. Yeah, so you can reserve GPUs, I think, by the hour. Let's just see right here. For as little as maybe like about $1 an hour, depending on what you need to do. So for what we want, we'll definitely not need anything like a 24 gigabyte GPU. We can get away with something much less. And then the last one is Google Colab. That one is free. You get your own like T4 GPU. It's a little older GPU, but you'll be able to this is allow. You'll be able to do some basic training here. The one thing you need to just understand is you'll just need to change the runtime type in the notebook to T4, okay, and that'll get you like a NVIDIA GPU. T4 is I think a few generations back now, but it is free. I don't know how much VRAM it has. Let's see, T4 GPU VRAM, 16 gigs. So that should be plenty. I have A4000, so I just basically plugged mine in right now through Thunderbolt. It's an external card, so it's also 16 gigabyte GPU, and it looks like Windows had just barely installed it, but can't really use it unless I have CUDA and all that stuff installed, and not on Windows but on WSL, so Windows Subsystem for Linux. So to get that working, I actually don't do this often, so I might stumble too, but I just search for NVIDIA CUDA toolkit, and I'm brought to the first result. And it's as easy as just clicking download now and then following some of the instructions here. So I think we want Linux, actually, not Windows. We want Windows subsystem for Linux right here. So we follow this instruction. I took the dev network. We just need to copy and paste these commands and run it in Whistle. And then we just need to follow the additional installation instructions after that. But let's take it a step at a time. So I like to choose the network install so that it just downloads the files as necessary. So let's start up a terminal window. In this case is Ubuntu. So I'll just copy the first command and I'll paste it, and I'll get that keyring, and then just install that keyring. Okay. Let's see. Okay. And then sudo apt update. I already know that command. So update with new repos, you'll start to see that now instead of just pulling from Ubuntu, it's going to also pull from NVIDIA. So now we have access to packages from NVIDIA. And the one that we want is the CUDA toolkit. So once that's done, we can just install the CUDA toolkit, and it's a pretty big file. It's about 6 gigabytes, so it's gonna take some time. So anyway, post installation. So once we're done with that, I believe that in order to really be able to use it, like let's say you wanted to compile llama.cpp, for example, and you need access to NVCC, which is NVIDIA CUDA compiler. you do need to add some environment variables. And I think if we take a look at this here, I think it's driver installation, maybe, or post installation. Post installation, yeah. You want to go to post installation, and then you'll have instructions to add to your path variables the path to the CUDA binary files with like the compilers and everything like that, and also the library files. So after we have installed the CUDA toolkit, we'll be able to just add those to the path. So as far as like NVIDIA SMI and things go, I think that's already like installed with the CUDA toolkit. I am not sure about NVTop. Let's try that too. But I believe, I don't know how it is with WSL. So anyway, yeah, let's come back to this. I'm gonna pause the recording and then I'll start again. Okay, so the CUDA toolkit's installed, and now we need to do the post installation action. So so we're going to copy this path to the binary file. So we're just going to export path, concatenate whatever we have currently in our path, and then additionally just add this USR local CUDA 13 bin path there. How we do that is we're going to modify our bash RC. So what you just want to do is you want to edit your bash RC to include those new variables. I'm going to do that offline because I have tokens in there, but at the end of the day, you just append those two lines in, and you should just be able to source the bash RC, and you should be able to have access to MVCC and all those types of things. So I'll do that offline. Okay, so I've edited the bash RC file, then I just need to source it, and I can check that everything is good if I type NVCC, and it should come up with this error here because I have no files to compile, but this means I have CUDA installed. And let's see if I have NVIDIA SMI. I guess I don't. Wait, let's see. I know in Whistle there's actually a caveat. Let's see, NVIDIA SMI. Okay, so this guide is pretty helpful too because it gives you some additional information about CUDA on Whistle, and I think some of the files are different. So, for example, what was this saying? Here, NVIDIA SMI, okay, is not on the regular path, but on this path here. So if I run this, that's not expected. Let's see, USR, oops, USR lib. What do we have? Whistle. Okay, so NVIDIA SMI, maybe we just need to restart this, probably. Yeah, let's just restart this. So I will restart the computer and see what happens. Okay, so I really don't know what was up, but after a few restarts, yeah, the NVIDIA SMI works now, so everything works nicely. I have the drivers installed. You can see here that I have 16 gigs VRAM, CUDA version 13, and yeah, just the driver version is 581. So I think we'll be ready to train soon. Yeah, I just wanted to get this set up so that we don't have to go through all that the next time we meet. So thank you.